It's hard to believe, but it was only back just a year and a half ago, in mid-2022, that we had yet to encounter the very first science images released by James Webb.
Astronomers have made an unexpected discovery using the James Webb Space Telescope. It spotted 6 massive galaxies that existed between 500 million and 700 million years after the Big Bang that created the universe.
In the time that's passed since, we've got a revolutionary glimpse of our universe, replete with tremendous new discoveries. The farthest black hole, the most distant galaxy, the farthest red supergiant star, and many other cosmic record breakers. That's extremely impressive. But James Webb, as told, was built to enhance the effort to understand not only what our universe is and how we fit into that cosmic story, but also the story of how the universe evolved and grew up to be the way it is today. Thus, despite presenting a series of astounding, upgraded images unveiling our universe in unprecedented clarity, James Webb now continues to try to lift the veil on the secret of deep space, helping us refine our own story, a story of our origins and how similar and different we are to the rest of the universe. Join us as we dive into some of the recent stunning discoveries of this scientific goldmine. Using NASA's James Webb Space Telescope, astronomers have spotted a failed star, or brown dwarf, that shows signs of possessing an aurora. Auroras are more familiar as the northern and southern lights, which are caused by charged particles from the sun-striking molecules in Earth's atmosphere. They're usually seen only at high latitudes, because our planet's magnetosphere funnels these particles toward the poles. Auroras have been spotted around other planets in our solar system, such as Jupiter and Saturn, and even over active moons like Jupiter's Io and Saturn's Enceladus. All of these light shows are likely caused by bombardment by charged solar particles. So the newfound apparent aurora around the brown dwarf, designated W1935 and located over 40 light-years from Earth, is mysterious. There are no stars close to it that could be providing the charged particles to fire it up. Brown dwarfs are larger than gas, giant planets, and smaller than stars, but form like stars do from a collapsing cloud of gas and dust. That means that most brown dwarfs are often isolated from stars, just like W1935. They get their slightly unfair nickname, failed stars, because they don't have enough mass to trigger the nuclear fusion of hydrogen to helium at their hearts, the process that powers stars, at least in their main sequence lifetime. The potential aurora over W1935 was indicated by infrared emissions from methane, spotted by James Webb. When methane emissions like this are seen over Jupiter and Saturn, they are the result of atmospheres being heated as charged particles whip down magnetic field lines and hit atmospheric particles, also creating aurora. So the study team thinks that the same applies to this isolated brown dwarf. With a lack of an external solar wind to cause the brown dwarf's likely aurora, the team believes that there may be some internal process occurring within the brown dwarf supplying energy to its atmosphere. Alternatively, interstellar plasma could be striking W1935, or the brown dwarf may not be totally isolated and could be receiving an influx of particles from a nearby active moon. The team of scientists, led by American Museum of Natural History astronomer Jackie Faherty, made the discovery while investigating 12 brown dwarfs with James Webb. Among these were W1935 and W2220, two very similar brown dwarfs that the $10 billion telescope found were near clones of each other, sharing similar temperatures and brightness, as well as near identical compositions of water, ammonia, carbon monoxide, and carbon dioxide. However, W1935 differed from its near twin in having methane that was emitting infrared light. On W2220, the same chemical compound was absorbing light. As Faherty said in a statement, "We expected to see methane because methane is all over these brown dwarfs. But instead of absorbing light, we saw just the opposite. The methane was glowing. My first thought was, What the heck? Why is methane emission coming out of this object? Modeling the atmospheres of the brown dwarfs to determine the cause of the methane emission, the team found the atmosphere of W2220 cools with altitude, but the atmosphere of W1935 seems to be experiencing a temperature inversion that sees its atmosphere heating up at higher altitudes. According to research lead modeler Ben Birmingham of the University of Hertfordshire in England, this temperature inversion is really puzzling. We have seen this kind of phenomenon in planets with a nearby star that can heat the stratosphere, but seeing it in an object with no obvious external heat source is wild. That led the team to turn to Jupiter and Saturn for an explanation, finding temperature inversion is prominent in the atmospheres of these solar system gas giants too. The leading theory for this is heating by the same process that is creating an aurora. Aurorae have been used to explain unusual qualities of brown dwarfs before, such as radio emissions from warmer examples of these failed stars. However, the Webb telescope observations of W1935 represent the first time that a methane emission from a brown dwarf has been spotted, indicating an aurora. As Faherty concluded, with W1935, we now have a spectacular extension of a solar system phenomenon without any stellar irradiation to help in the explanation. With the James Webb Space Telescope, we can really open the hood on the chemistry and unpack how similar or different the auroral process may be beyond our solar system. Another remarkable finding: physics-breaking rogue objects spotted by James Webb are emitting radio signals rarely seen from other worlds that scientists can't explain. The rogue planets spotted by James Webb lie in the Orion Nebula, a long-time observational hotspot for astronomers. In total, they number over 500. This discovery bonanza was possible thanks to Webb's ability to pick up infrared radiation emitted by these relatively young planets. Bizarrely, though, about 80 of these planets exist as pairs. Similar in mass to Jupiter, the planets orbit each other at distances ranging from 25 to 400 times the distance between Earth and the Sun. These tangoing duos, called Jupiter mass binary objects or jumbos, pose a huge mystery for astronomers because the existence of these worlds challenges current theories of planet formation. Some scientists think these objects may not even be planets, but rather previously unknown entities that are larger than planets but smaller than brown dwarfs, which are sometimes called failed stars, because they blur the line between planets and stars. Webb's data showed that jumbos generated infrared radiation, but the new study's authors wanted to see if these dancing objects produced radio waves. That's because different classes of cosmic objects produce distinct patterns of radio emissions. For instance, planets like Jupiter spew several types of radio signals, including gigahertz frequency emissions thousands of times higher pitched than an FM signal, partly because of their magnetic fields. Notably, spotting such signatures from the jumbos could help resolve their identity. As lead study author Luis Rodriguez, a professor emeritus at the Institute of Radio Astronomy and Astrophysics at the National Autonomous University of Mexico, said, the observations could also explain why some objects have detectable radio emission and others do not. To find radio wave snapshots of the Orion Nebula where the jumbos reside, the scientists combed through archives of observations maintained by the U.S. National Radio Astronomy Observatory. They found just one pair that apparently emits radio waves, Jumbio 24. Itself an oddity among the oddball objects, it's the heaviest of the jumbios, and also the one with the tightest space between its component planets. A decade's worth of data the research team collated showed that the radio waves remained steady but strong, with a power of roughly 1/4 of a ton of TNT and frequencies of 6 to 10 gigahertz. The radio waves also weren't circularly polarized, meaning they lacked spiral, twisting electric fields. But these features aren't what astronomers expect of signals created by planets. As Rodriguez said, circular polarization is an unambiguous indicator of the presence of magnetic fields. Without this, the team can't say definitively that the signals come from Jumbo 24. Besides, radio emissions from other exoplanets are more variable and less intense. Even if Jumbo 24 isn't a pair of planets, but rather another type of cosmic duo, the signals are unusual. Signals from brown dwarfs are very different from the newly identified radio beams. The beam's brightness and frequency even ruled out the possibility of pulsars, the rapidly spinning cores of dead stars that produce pulses of radio waves at regular intervals. The researchers also estimated the likelihood that the signals originate from an object behind Jumbo 24 and found it to be exceedingly slim, at just 1 in 10,000. And in case you were wondering, the signals probably don't originate from aliens. According to Rodriguez, the fact that both components emit at similar levels favors a natural mechanism. With the research at an impasse, the team is applying to the National Radio Astronomy Observatory's Very Large Array in New Mexico to collect data from free-floating planets. Until then, the radio signals will remain a mystery. While NASA's $10 billion James Webb Space Telescope grabs a lot of headlines, groundbreaking astronomical discoveries aren't exclusive to such high-tech tools. Take, for instance, the image. The highest resolution photo of gamma rays ever captured. Achieved without the need for advanced spacecraft or terrestrial arrays, this scientific feat was accomplished using a simple stratospheric balloon, layers of photographic film, and some ingenious engineering prowess. Late last year, scientists from Kobe University described the details of their experiment in a paper published in the Astrophysical Journal. The subject of their groundbreaking astrophotography was the Vela pulsar, located nearly 1,000 light-years away. This pulsar, which is a type of spinning neutron star formed when a larger star collapses in on itself, is a particularly interesting celestial object as it only stretches about 12 miles across and makes 11 rotations every second. Vela sends charged particles toward its poles that transmit in all flavors of the electromagnetic spectrum, radio waves, visible light, X-rays, and the highest energy wave of them all, gamma rays. This makes Vela unique among other pulsars, as a separate study in October of 2023 confirmed it's the highest energy pulsar known to science. Led by Kobe University astrophysicist Shigeki Aoki, the team bundled sheets of photographic film together and sent the stack skyward, with the help of a stratospheric balloon, up to 25 miles into the Earth's atmosphere. Because the film was stacked like a pancake, the team could track the trajectory of gamma-ray particles, and the apparatus's position in the stratosphere eliminated any would-be ground interference. This particular photographic film method is actually pretty old school and relies on the principle that film turns dark in the presence of radiation. This is similar to how Kodak detected evidence of U.S. a bomb testing in 1945, though they likely didn't know it at the time. To make sure the balloon captured gamma rays emanating from the Vela pulsar, the team attached cameras that recorded the balloon's position in relation to Vela. However, this still didn't solve the problem of time-stamping these trajectories. So, the researchers developed an ingenious method of subtly shifting the last 3 film layers at regular intervals, but at different speeds, mimicking how hour, minute, and second hands work on a clock. When comparing these 3 layers, the team could essentially build a chronology of precise impact times. The result? The highest resolution image of gamma rays ever captured. As Vela pumped out gamma rays like a lighthouse at night, according to a press statement, this stack of film suspended in Earth's stratosphere captured 7 million tracks with an accuracy of 1/10,000 millimeters. Aoki estimates that this resolution is 40 times higher than your usual gamma-ray telescope. So, while James Webb and its high-tech companions will continue producing mind-boggling and headline-grabbing science, never underestimate the power of a stack of film and a well-placed balloon. Excited information. The first data has just released to the public from a sky survey comprises an X-ray view of half the sky over Earth, encompassing almost 1 million high-energy cosmic sources, including over 700,000 supermassive black holes. This catalog, dubbed the eROSITA All-Sky Survey Catalog, or ERAS-1, was published on February 1st. It constitutes the largest ever catalog of the universe's most powerful sources of energy, like exploding massive stars and black hole-powered active galactic nuclei that shine brightly in X-rays. The release also details the largest known structures in the universe, cosmic web filaments of hot gas that connect galaxies in clusters. The results show that, in just half a year of operations beginning after launch on July 13, 2019, eROSITA has managed to discover more high-energy X-ray sources than has been found in 6 decades of examining the sky. Considered a major milestone in the 60 or so years of X-ray astronomy, ERAS-1 could help answer some of cosmology's biggest questions. How did the universe evolve, and why is the very fabric of space expanding at an accelerating rate? Accompanying the ERAS-1 data are almost 50 scientific papers published across a range of topics, adding to an existing 200 papers already written using data from the eROSITA telescope. The main aim of eROSITA is to use clusters of galaxies to observe how dark energy accelerates the expansion of the universe. These 250 or so papers, however, demonstrate the extent to which the instrument and its data have gone beyond this goal. These papers include the discovery of over 1,000 superclusters of galaxies, the revelation of 2 quasi-periodic erupting black holes, and the determination of the impact that stars' X-ray radiation has on water and atmosphere retention of planets that orbit them. According to spokesperson for the German eROSITA consortium, Mara Salvato, the scientific breadth and impact of the survey is quite overwhelming. It's hard to put into a few words, but the papers published by the team will speak for themselves. The ERAS-1 data consists of eROSITA telescope observations conducted from December 12, 2019 to June 11, 2020, from across half the sky over Earth. During this period, the Space Telescope detected around 170 million individual particles of X-ray light, or photons. Processing these photons revealed 900,000 X-ray sources, of which 700,000 are feeding supermassive black holes that power quasars at the hearts of active galactic nuclei, regions in the centers of galaxies, so bright they can outshine the combined light of every star in those galaxies themselves. Also seen in the ERAS-1 are 180,000 X-ray emitting stars in the Milky Way, 12,000 clusters of galaxies, and even exotic classes of X-ray sources like binary stars, supernova remnants, pulsars, and other such objects. These are mind-blowing numbers for X-ray astronomy. Andrea Merloni, eROSITA principal investigator and first author of the eROSITA catalog paper, said in a statement, "We've detected more sources in 6 months than the big flagship missions XMM Newton and Chandra have done in nearly 25 years of operation." The data release is also impressive in terms of the speed of its observations, with the sky over Earth imaged at multiple X-ray energies. In addition to this, eROSITA is incredibly precise, with its first data release also pinpointing positions in the sky from which individual photons are received, as well as these photons' arrival times and energies. Along with the release, the eROSITA consortium has also made available the software needed to analyze data from the X-ray telescope, as well as catalogs that go beyond just X-ray data. A new detailed investigation of asteroid samples has provided further evidence that the organic molecules which gave rise to life to our planet were brought here by ancient comets. These space rock samples were returned to Earth by Japan's Hayabusa 2 mission, which visited the spinning top-like space rock Ryugu in 2018. Hayabusa 2 spent around 18 months studying the asteroid and collecting surface material, which has proved to be a treasure trove of information about our solar system. Ryugu, formerly known as 162173 Ryugu, is a 870-meter-wide near-Earth asteroid that lacks a protective atmosphere. This means its surface is directly exposed to space and can gather interplanetary dust, which changes the asteroid's surface composition when struck. The team of scientists behind the new developments in the quest to find life's origins found 5 to 20 micrometer-wide melt splashes created when cometary dust in particular pelted the surface of Ryugu. And within these melt splashes, the researchers found small carbonaceous materials similar to primitive organic matter. According to team member and Tohoku University Graduate School of Science assistant professor Megumi Matsumoto, this organic matter might be the small seeds of life once delivered from space to Earth. Comets tend to exist in wide orbits around the Sun, which means they spend most of their time at the frigid outer edges of the solar system. But when they do sweep into the inner solar system, solar radiation heats their inner icy material. That causes the material to transform straight into a gas, a process called sublimation. As this gaseous material explodes from the comet, it carries with it some of the object's surface material. Not only does this create the characteristic tails and auras, or comas, of comets, but it also leaves trails of cometary dust around the Sun. When Earth passes through these trails, we witness meteor shows as the dust fragments burn up in our planet's atmosphere. However, this cometary material is far more likely to make it to the surface of atmosphere, less bodies like Ryugu, where it can be preserved. Thus, studying those dusty remnants on the Hayabusa 2 samples could reveal clues about the material in the early solar system. The melt splashes studied by the team were created when the asteroid's surface material was struck by cometary dust, with the two materials melting and mixing together during impact-caused heating and eventually cooling off. The spongy carbonaceous materials found in the Ryugu melts differ chemically from organic matter, usually found in cometary material because they lack oxygen and nitrogen. However, this could hint at how the material was formed in the first place. The research team proposes that the carbonaceous materials formed from cometary organic matter via the evaporation of volatiles, such as nitrogen and oxygen, during the impact-induced heating. This suggests that cometary matter was transported to the near-Earth region from the outer solar system. Sealed with the melts as further evidence of their origin are tiny voids caused when the impacts released water vapor from materials on Ryugu's surface. This water was captured by the impact-heated matter. Matsumoto and the team are continuing to examine Ryugu samples collected by Hayabusa 2 in the hope of discovering more melts that may hold within them evidence of cometary dust strikes. The hope is that will deliver more insight into the transportation of primordial organic material to the space around Earth over 4 billion years ago, prior to the emergence of life. In addition, astronomers are beginning to write a whole new chapter in our understanding of exoplanets, planets beyond our solar system. James Webb, our best space instrument, are designed not just to detect these distant worlds, but to reveal some of their characteristics. That includes the composition of their atmospheres, which could offer clues to the possible presence of life. The recently discovered super-Earth, TOI 715b, might be making its appearance at just the right time. Its parent star is a red dwarf, smaller and cooler than our Sun. A number of such stars are known to host small, rocky worlds. At the moment, they're the best bet for finding habitable planets. These planets make far closer orbits than those around stars like our Sun, but because red dwarfs are smaller and cooler, the planets can crowd closer and still be safely within the star's habitable zone. The tighter orbits also mean those that cross the faces of their stars, that is, when viewed by our space telescopes, cross far more often. In the case of Planet B, that's once every 19 days, a year on this strange world. So these star-crossing planets can be more easily detected and more frequently observed. That's the case for the Transiting Exoplanet Survey Satellite. which found the new planet and has been adding to astronomers' stockpile of habitable zone exoplanets since its launch in 2018. Observing such transits for, say, an Earth-sized planet around a Sun-like star and waiting for an Earth year, 365 days, to catch another transit is beyond the capability of existing space telescopes. Planet TOI 175b joins the list of habitable zone planets that could be more closely scrutinized by the Webb telescope, perhaps even for signs of an atmosphere. Much will depend on the planet's other properties, including how massive it is and whether it can be classed as a water world, making its atmosphere, if present, more prominent and far less difficult to detect than that of a more massive, denser, and drier world, likely to hold its lower-profile atmosphere closer to the surface. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.